Bueno, en primer lugar, buenos días a todos. Muchísimas gracias por...
Right, let me start with a word of thanks. I want to thank you for coming. And you know that this is our 5th edition of Hackathon, which has been a real success, not just from the quantitative point of view, the number of people who've entered, but also because of the quality of the projects. So I just wanted to mention it and thank you once again. But now we're going to get started.
No, es que no va. Ahí, vale, es que no iba bien. Bueno, esta presentación inicial va a ser bastante...
We're going to start with a short presentation. The idea is that we want to hear from you who've entered the hackathon. We want to hear about your projects. We will tell you about the teams a little bit, about the members of the jury, the times, and logistics. We all know what a hackathon is. Why is our hackathon different? Well, because every project, every team is completely free, deciding what they want to do, if they want to improve an existing project or something completely new. Supposedly, if we can last, we're going to be here for 3 days. And the idea is that projects won't finish here, but rather they can be submitted again in future editions to be further improved, and hopefully that way we can disseminate and foster local talent. These are our members of the jury, starting with Oscar Garcia and Vicente. I don't know if the sound is a bit echoey. Anyway, let's continue with the members of the jury. Dani Garcia and Jose Selvi, they're going to be checking the code that you program. Raúl and myself, Monica as well. Well, many of you know my name at least because of Telegram, because of our messages. So, you know that we've given you a hexadecimal code to identify your team. That will help anonymize scoring so that the landmarks, landmark 1 or 2, we will never see the name of the team. We won't be able to identify which team the code belongs to. We will just see the code. We're not going to be giving transparently the scoring, and really we think it's best, at least in the initial stages, because there will be very few differences in team scores at the beginning. The main point at the beginning of the hackathon is your explanations. At the moment, at the beginning, we don't have any code that you have prepared previously. So the idea is that at the beginning, the jury will have to assess how functional what you provide is, and we will mostly be valuing how innovative and original your proposal is, how complex it is from a technical point of view, the quality of the presentation as well. As I said at the beginning, initially, your explanations, your presentation of what you're doing will be most important. And last but not least, how it will be important for you to ask other teams questions and also to reply to questions that are asked to you conveniently. Please remember that in the questions you ask and in your replies, that will be scoring points or not. The idea is that this is very collaborative, that this is an open source community, and that there's interaction and feedback. Let me just remind you that you have also selected a code randomly, like pulling it out of a hat. That's what decides who's going to be presenting projects first and last. And then the idea is that at the end of the process, the order will be inverse. We will reverse the order. Just as a reminder, you have the hexadecimal code. Remember that you have to keep that one secret because it identifies your team. And then from 1 to 10, just saying who will be intervening first and last. Right. Here we have Cyber Spartan. Or Theon Spartan, sorry, first. Well, you can see up on the screen, Alex will be third. Alex, sorry. Anyway, this table is just a reminder of how you need to introduce yourselves. And that's enough from us. We're ready to start the hackathon, but before we do so, we're going to do something special this year, something different. We want to pay tribute to people who have been very involved in hackathon to death, really. They stand for best efforts, for devotion to hackathon. And I'm not going to tell you who they are, but I will give you a good clue. They come from Albacete in eastern Spain. And what do they do to come here? Well, they catch a train. As soon as they get here, they go mad about their keyboards. Here we have them, Alfonso, Ricardo, Guillermo, and Germán, who have been champions 3 years running. I'm pretty sure that they want to make this year their 4th award. So a warm round of applause for all of them. They really deserve it. Welcome, one more year. So who else is going to be here this year? Juanjo, who was the winner of the Dubai Hackathon in 2017. Then the IoTech group, one of their members came second last year. And CyberWatcher, we have 2 members of the team right now. The third one will be joining us later today. They got a very good score last year. So this year is going to be a truly epic experience. All the best for you all. Break a leg or 2.
Para que lo tengáis claro.
Let me just clarify something. Whoever wins this hackathon will go down in history for this. It will either be our usual team with their 4th win, or it will be somebody who will wipe them off the face of the earth. So we're going to start with presentations. I think the presentations have been loaded on this computer so that we can show it up on the screen. There is a folder for each team. You can just click on it and you can access your presentation straight away.
Las preguntas, por clarificarlo, no entran en los...
Let me just clarify something. The Q&A session is not included in the 6 minutes that you've been given. So you'll have the same time for presentations. And then if there's time here, we will do the Q&A session here. Otherwise, we can go into the hackathon room and ask and answer questions from other members of other teams and from members of the jury. So can we start with Theon Spartans? They're first.
Vale, tenéis un poco por infraestructura. Tenéis el micro de mesa.
Let me remind you that you've got this mic here plus the roving mic. And you've also got your control here for clicking on the presentation.
Bueno, buenas a todos.
Good morning, everyone. We are first. There's a defibrillator outside. I was very glad to see it, just in case. We're Theo Spartans, and here we are with Waldo, a tool for detection and prevention of attacks. We thought that Phay21 was not distributed, and we thought, well, why not do that? We decided that was a good idea in the end, that we could add more functionalities for this special tool. The idea would be having it all centralized somewhere. It might be ELK now. And then the checking interactions on the logos, seeing how many people try to access on the logs, and then scoring on the IP, and then depending on that, sending alerts. Or the idea is that all nodes will provide information, and it will happen on all nodes without depending whether you block them or not. Right, I would like to tell you a little bit about the technologies that we're going to be using: Docker, Python, MongoDB, and ELK. With Docker, we will raise the infrastructure, we will have the containers, and then the programming language will be Python, because it's one of the most popular ones. And because of that, it has all these libraries that will be very helpful for Python connections, for the ELK, for queries, for insertions. Python has then these libraries that allow for connections between Python and MongoDB. Those interactions will be further enhanced. About the database, we decided to use a non-SQL MongoDB, and we decided to use that because the information we will be handling, it won't be many tables, they won't have ratios, and we didn't want to use really SQL databases. And because all the logs need to be centralized, and because we want a program that is a standalone, because ELK is the most popular one, we thought that would be good for our Waldo application. We would like to show you the infrastructure now and tell you about the interaction. This is what we want to develop with 3 virtual machines, using it for tests. The machines will be sending the logs to ASCII, and then from the Python container, you can see that that it's all with Docker and Docker Compose, because we want the application to be easily implemented, not just for very technical users, but more generally speaking. So the Python container will check the Elasticsearch, and then that information would be saved on the database for queries, for scoring. The idea is that we would then check the score and execute the actions, sending the commands to the machines, or later maybe if there is a firewall, well, the ratios would be sent to the firewall. Last but not least, we would like to tell you what we want to develop here compared with the infrastructure that we had previously. What did we bring? The Docker Composed part that will lift the infrastructure, and from the SSH connections and from the Phay21 logs, that's what we would be working with initially. The secure load, the outload, the fail to band, and then from the LK start, all the queries of the logs that we had to get the information. Then we also want to check the blacklists, because we want to check up against the API. We have the IP, and we want to see if that's a reported malicious IP. If it had been reported by a previous user, whoops, the mic is not working properly now, well, that would have a greater weight for scoring, which is the main part of our project, because the scores will tell us which actions need to be determined. So in MongoDB, once we have the IPs, we would have the scores there, and depending on the points, if they're very high, we will have more restricted banning, whereas if they're lower, then we might go for 1 hour or 2 hour banning. So if we have banned, for instance, an IP for an hour and we see there's no repetition, no iteration, then we need to lower the score. And that's how we decide which measures need to be taken. And this is the last part of our project. It has to do with the measures to be taken in Waldo, whether it's banning or debanning from the different nodes. So that's it. That's our presentation for our project. Thank you for your attention.
No, les han sobrado 2 segundos, o sea...
Wow, they had 2 seconds still to spare. That's pretty good timing, if you ask me. We're going to now hear from the second team, and we'll leave questions for last. That's true. I forgot to mention it during the initial introduction. If you have a pen and paper, it might be a good idea for you to take down notes for questions to be asked. If you need pen and paper, please just let me know.
Bueno, buenos días a todos.
Good morning, everyone. We are Cyber Watcher. That's the name of our team. There are 2 of us at the moment, Javier and Miguel Ángel, myself, and then Santi will be joining us a little bit later. This is our project, SOAP. Well, this is a platform that will be an authentication service. Our SOAP application, we work with 3 different elements: mobile terminal, coping, and biometrics. So let's start with the problems that we want to overcome with these 2. Firstly, the problem with storage, doing away with all those plastic cards that really have the same information, whether it is your credit card, your bus card, or parking card. They all have the same details at the end of the day. Because currently there are systems and applications that have already solved that side of things, so that the details are saved on the mobile phone, on your mobile phone. But what happens when we lose our mobile phone? We lose all that information. Our innovation is having a tool which, as Miguel Angel said, it will provide a SOAP integration in on any platform through an API, that is providing a service that will connect automatically with our platform, so that we can then offer 3 levels of service, where the user gives us a pattern or a PIN number, and then we would be sending a bus ID or an SMS, text message, or through push certification. Then with those credentials from authentication, we would double check logically, and then we would make sure then that we have securely identified that individual, and they say that they are who they say they are, and we can send them their details again. Why? So that users can access that information. For instance, you want to shop on Amazon. Well, you just need a PIN number, your print, and you can access your fingerprint, and then you can access, you can go ahead and do your shopping. Well, we have done some benchmarking. For instance, we have checked a mobile app, IoT, I believe he said, for credit card information, any sensitive information that's already there. That application stores those details internally on your mobile phone. Can you imagine when you lose your mobile phone? Well, you've lost it all. We want to centralize all that information so that users can follow those 3 simple steps and authenticate their details whenever needed. Who's our target audience? Well, it could be private individuals, banks, governments, anybody who wants a secure system for authentication. So what's the current situation? How far have we come? Well, we have done biometrics, encrypting, certificates, but it's very, very superficial study. Only last night we heard that somebody has been studying a library for fingerprinting, digital fingerprinting authentication, and we thought, hey, that could be a very good starting point for our project. That's when we decided that we want to investigate it further so that we can further develop it. Oh, and I forgot to mention earlier that the idea is we will be organize our data system in a certified manner so that we won't have anybody saving information for whoever, logically. We have to make sure and validate that that's right, we need certification. Right, we know how code will be developed. This is our schedule, our timeline. As soon as Santi joins us this afternoon, we will continue with our next development. Thank you very much for your attention.
Alex. Vale, sabéis que no tenemos vuestra presentación, ¿no? ¿Dónde está?
Es probable en el correo.
No, pero en el correo aquí tenemos conexión. No. Vale, pues pasamos al siguiente. Vale, que pase el cuarto equipo.
Right, we want to now hear from the 4th team because there's a little bit of a problem with their presentation. We're just going to solve this technical problem for this 3rd team. So we will continue with the 4th team, e-security. In the meantime.
Todo vuestro. Vale, a ver cómo conseguimos presentar modo pantalla completa. Esto. Es que está preparado para el PowerPoint con pantalla duplicada. A ver si ¿Puedo duplicar la pantalla en lugar de extender?
May I mirror the screen instead of expanding it?
Vale, el pasador por aquí. Este pasa. Claro, pero así me oye también como
Hola.
So we are the team introducing intelligent security, and it's not so much a tool as it is a service as we devised it. And we thought of it as a security management and monitoring for SMEs. I think it's too wide a scope, so let me specify what it really means. So what about the team members? It's three of us. That's Javi, that's him, and he is a cybersecurity analyst for Deloitte, and he is a developer as well. And Lucas, who is the one on the left side, and he works as a CDO at Telefonica, as a researcher and developer as well. And myself, Santiago, working at CyberSoc as an analyst, although I'm a bit more focused on strategy and SOC training, etc. So our system, our service, was devised as a service with a set of capabilities by means of which a company or some people who do not have advanced knowledge on cybersecurity to manage or stay up to date on the cybersecurity ecosystem within their organization. We thought of it as a service with different capabilities such as security intelligence, that would be finding domains that have been neglected for the company, or pastebins, and also passwords or any leaks within the company. So everything having to do with threat intelligence. There are other capabilities such as threat hunting, where we can gather different events and logs from operating systems and taking them to a central repository such as a data lane, or using correlations as well, and also producing a series of warnings or alerts so that a given person can see this real time without advanced cybersecurity technical knowledge. And that way they will get a general idea of what's going on within the company. And then I guess what's making the difference here would be the way that someone who might not know how to use a handset or security programs, still they can interact with it all and learn what's going on. And so we added the smart assistant, where what we want is to interact. If there's a threat or anything else, using your voice or your cell phone, so you can have virtual assistants, same as Google Home or things of that kind. So this is an idea that came up, well, from different approaches. First of all, personal experiences. Before working at our current companies, we've always been working with the small companies and their security, and we've realized that most of those are impacted by security breaches, which are quite basic, and that could be easily sorted out. And oftentimes they are not sorted out because they find there's a lack of resources, or only a few bunch of employees who are cybersecurity experts. And maybe if we got a bit of a more independent system, we could monitor it all and allow those people to be aware of what's going on and problems that might arise. So basically, the specific target of our service would be SMEs. Still, it could be extended to other organizations just by following a series of changes. So far my explanation, and my colleague will pick it up now. So the idea is to have a tool so where small companies can interact with cybersecurity data. So this is a SIM evolution. First, back end, where we've got the data infrastructure. Then we have a backend and a data lake, and all having to do with warnings and alerts. And then the mobile app as a front end. Here we see the structure of our backend. Right now, we've chosen SIM, well, Splunk actually, probably you know about that, otherwise you will hear about it throughout the presentations. Still, the final goal would be using a Pensa's system as a search, but because of our team, we thought that for 3 days it would be easier to use a system we were all familiar with. The backend will be using Python, which is Flask, now out of the beta version, so that's good news for everyone. That will use an API to interact with the front end and other services. And then we will have kind of a virtual infrastructure on Amazon Web Service that will be kind of a company with several servers and machines. And then with US Query, we'll produce the whole structure of services and processes, and then adding it to data lake. And then my colleague will explain. We also have a mobile app, quite simple and crystal clear, so that everyone can use it. And then a virtual assistant that will replicate information and will run as an interaction. On top of everything else, there is a communication system, as my colleague just explained, which allows for a proper interaction. This is all part of innovation. And so we have some clear features. We have an interface with SMEs. And the difference between a regular SIEM and our project would be that a regular, ordinary person can use our app and has real events and can manage every company without in-depth knowledge. And as we said, there's nothing out there similar to what we have. We got some novelties, and in the end, you need to have the technical expertise in order to use them. So far, our roadmap. So thank you very much.
Sí. Somos generosos en el margen, nada. No se trata de apremiaros, pero por ser justos en el tiempo tenemos que ajustarlo. Vale, que suba Ablex, que en principio deberíamos tener.
So let's have Ablex up here.
Presentación ya por aquí. Un momentito. Vale, darme un segundo que la copio.
Hola, buenas a todos. Digo, ¿cómo suena esto? Bueno, mi nombre es...
I'm Raul. Here's Danny. And we are actually 3 team members, but our colleague could not make it. Natalia could not make it. She will join us later today. This is our team's and project's name, Ablex, Authenticator, Bluetooth Low Energy External. That would be in Spanish. So the idea would be to simplify logging onto sets in a secure way. So by using Ablex, we would not need to enter a password into any device. So it would be easier and faster for all users to log into the same device without using different accounts. Ablex includes directory file root management. So any user using Ablex will have on the device all the files that belong to them without a personal account, because this is a cloud service. And it is scalable, so it can be used on a home computer, an SME, or even a larger company. But how does it work? My colleague is about to explain it to you. So this is the architecture that we mean to develop for our project. So we have 4 access here, basic access. First one, the token, which is BLE. Small device with a micro driver that is easy to use for the user, and it has all the identity elements with everything that is needed for the user. And this is the one that would lock, so to say, to the computer, to the PC of the user. So just by having your token with you, with the least degree of interaction, the user would get authenticated fast and in a reliable way just by pushing a button or just choosing a number, or maybe adding a second factor element of authentication, but a simple one, straightforward. And then that user computer would then log on to the cloud service or the server. I'll explain that. But the idea is that all the information is encrypted through it. It would be kind of a middleman, but without too much operations, and so we avoid attacks on it. Then the server is the strong suit here. This is a reliable server that is the one in charge of everything about cryptography, and so identifying, that is, whether the user is who they claim to be. So the server would send a challenge, let's call it a challenge, to the user using public key auxiliary cryptography, and the user would need to reply back. And there the register would happen and the identity would be checked. And then we have the file system, probably cloud-based, and the server is the one reporting back to the system and explaining whether the user has been identified, and then the cloud back to the PC explaining that the authentication has been completed. On the computer, it would be all transparent, so to say. You wouldn't see much of these operations. And then on the server, you can try and add some kind of hardware security module, making sure that all cryptographic actions are performed in a secure way, also preventing potential attacks on the server. So what are we going to use in order to carry out the project? As Danny said, we will be using a micro driver based structure. We will be using one by Nordic Semiconductors N52840, which we can find on development boards with the DK boards or the dongle USB and our F52. This chip is very much useful because it has DL, also has hardware cryptography capabilities, and can be used for the token because it is a small device, and also an HSM module that will be added to the server. This way, all cryptographic operations will be conducted in a secure way and outside of the computer's hardware that could have been attacked by any kind of malware. So why AbleX? As we've said already, we try to be fully transparent with the idea that a user, just by coming close to the laptop and just with a small notion, they need to log without entering password or username. That means that for a company, well, at a given company, thousands of employees can log onto a device without having the device with them, just moving around the infrastructures. So why AbleX, once again? Because we've seen that we are not identified by passwords, but we're identified by the fact that we're people. Thank you very much.
Siguiente, IoT Vigilant. Vale, espera que esto, con un poco de suerte, os lo pongo aquí en extendido. Vale, Por este, la derecha, justo
Vale.
esa para allá.
Vale. Bueno, buenos días a todos.
Good morning, everyone. This is IoT Vigilant project. Right to left, we have David and Guillermo, and then Carlos, who couldn't make it today, but he will be joining us on Friday. We were former colleagues, and we work on pen testing. This is IoT threat detection. This is based on abnormalities, or anomalies rather. We monitor the network, the web rather. We use machine learning for detection, and through processing, we produce a series of alerts or warnings. Simple as that. Why? Well, probably we should dwell on that, but the number of IoT devices is growing at an alarming rate, and those devices are target of attacks for botnet farming, phishing, intrusions, etc. So the idea here would be to learn how to detect the attacks in a different way and be up and ready for those that we are not aware of yet. Traditionally, attack detection or breach detection has been focused on signature mainly, which is a bit more useful for past settings, so to say, because in the past attacks were better known, there was fewer attacks and it was easier to detect. But now we do have a setting or an environment where devices are new and attacks are new as well, and they'll change. So we need to learn how to detect those attacks that we are unaware of now. So what's the basis here? The idea is that IoT devices are different from those servers because they will be simpler and predictable. Right now, we don't have any solutions that are open source focused on IoT malware detection just like that. So, what are typical systems that we are familiar with? Snore or Suricata, that are IDSs. They use preset standards and signature and other elements. So the requirement that we set in order to solve the problem is using a predictable condition setting. That is what gives us what we get out of IoT devices. And we find this is perfect for machine learning. So we've realized that there are some solutions such as IoT security or single box IoT. And in these two cases, we see these are patented. And so there's another one, Hackzilla, from Brazil, which has some limitations in its implementation, though, and we can discuss that later. But I'm referring here to the algorithms that are used. So what are the advantages of IoT Vigilant? It is open source, of course. We'll be using a detection algorithm with ML that we think will improve intrusion detection rate, and we will try and focus it on having a simple deployment or easily deployed. What we want to develop is an unsupervised ANIDS, which is an IDS on the network that will detect anomalies and will not be supervised, so it'll be unsupervised. As we said before, we are unaware of the attacks they'll be, so we cannot have ML tagging and we cannot be up and ready in advance. We cannot train the system. So the idea is to use this unsupervised system. So what will we be using? A full open source framework, Elasticsearch, Grafana, Flask as well. We are planning on that. And mainly the scikit-learn, which is the ML library with Python that has thousands of different algorithms. On top of that, the idea is that, well, you'll see that in a minute, but we can combine the learning from different settings to increase the system efficacy through machine learning. Our target with this project would be to for large business networks where we have IoT miscontrol, hospitals, industrial environments as well. Another idea would be that we do not want to cover it all. What we mean is, well, we mean to detect unknown anomalies. So the idea is that we do not mean to cover it all. We just want to design a system that can be easily integrated and embedded into other devices, or, for example, signature systems, and that way we can have an homogeneous defense system or security system. Since we want it to be straightforward and easily deployable, of course it can be deployed in our systems such as DIMMs or home settings. Where are we? We're starting from scratch. Haven't done anything so far. We just had the research stage on machine learning, but we are still trying to specify what we are going to use. And that's the time for a decision. We will have to develop and embed all system modules as well. What about features? What features do we have here? We will be able to detect devices under attack, devices that are used for an attack, and we will have full visibility of the network because we will see that some are behaving weirdly because they showed up or gone away. And that's been all. Thank you very much.
Una cosilla simplemente. Bueno, veréis que andamos por...
See that there is a tablet around there for time tracking. I wish you could all have as much time as you need, but you are 14 teams, so that's a no-go. That's the cutoff. And not so much about this presentation, because it matters, but not so much. But I guess this is a good training for the final presentation. You'll be given 11 minutes, but you need to show the functionality and the features, so you need to be aware of the time limit as set by the room, and that's all. It is not that we are dragging you around, but that's because we're forced, and also a teaching lesson for last day's presentation. Can you check that you can hear the sound from my computer or my device? Can you hear?
Sí, es enchufa el jack y demás.
Plug the jack in. The volume sound should be heard now.
Bueno. A ver si ponemos... Yo creo que sí, ¿vale? Tiene pinta. Si no, páralo ahí y lo intentamos organizar, ¿vale? El pasador es este. ¿Sí hay audio o...?
Sí, se ha cambiado.
Sí, he cambiado aquí, esto lo puse, te quito esto. Pero... Bueno, pruebo, a ver. Perfecto, ahora ya.
Lo pusieron duplicado para verlo yo aquí.
¿En duplicado?
Sí, sí,
vale. Sí, puede ser. Todo tuyo. Vale.
Buenos días. ¿Qué tal?
Morning. Let's get started. I'll need to be brief, but 6 minutes. Well, I have to be fast. Juanjo, that's my name. I work at BBVA Next Technologies. I try to make sure that what's developed at the bank is more secure. And first, a question. What's common in all those apps? WhatsApp or Telegram, Skype, Gmail, Outlook, Excel, Google Sheets, and Notepad. Notepad, well, it's been a bit crazy, right? But people tend to use them for storage and sharing secrets. And what's a secret? Password, an API key, an access token, credit card, a PIN code, a cryptographic key. the hexadecimal code that we've been given, for example, to identify our teams. So anything that we find is valuable and we don't want anyone else to know about. So haven't you ever seen a password on Notepad, or maybe you've been forwarded the credentials, or maybe the well-known Excel sheet on Google Drive with machine IPs and passwords for SSH connection, for example. So if that kind of information falls in the wrong hands, you can picture what happens, as predicted by The Simpsons.
Hasta ahí la tontería del audio.
And thank you, that was why I needed the sound. Creepy, isn't it? There are some apps out in the market, well, apps that helps us out here. We have KeePass, probably you know that, which is a local file and a master key where we enter our secrets, and it's encrypted and then on a local file. KeePass is quite good, isn't it? But if we want to have our secrets anywhere or from any device, we need to carry it around and we need to send the file over and over. So this is a drag, and it doesn't solve the problem of sharing secrets with someone else. What about you want to send a secret, I don't know, my bank account, if you want to check in something? So it's a drag. Again, you need to send it and resend it, and then the master key somehow, and once again the same problem. And then on KeePass, if you forget the master key, your secrets are gone for good. Then LastPass, a bit not so well known, but it's an online app also based on a master key. There is a recovery system if you lose the key, but I find it is not secure because you need to keep on your device information to recover your secrets, and information which I find should not be on the device. I'm not a fan of it. You can share secrets with other users, there's a feature, but you need to pay for that, as well as others. And it is not cool, but LastPass is not open source, so we don't really know what they do with our secrets. Despite it all, there is another hindrance here, the worst one, why I would not use it and why many people don't use it. This one, serious vulnerabilities in the past. So what's my proposal? This is an online app where you can upload your secrets kept on a server, and you can use it anywhere. And you might say, how come? We want to protect our secrets. How will we keep them on a server? They will be encrypted. And we will be encrypting them with client-side encryption, where client-side, that is the device, the browser, whatever, you log in with your password, then you are sent to a cryptographic key, and when we enter a secret, we use the cryptographic key, and then we all send it. This is all done on the client side with JavaScript, and this is then sent to the server. And then this is all kept on a encrypted database, and with the password, we recover them and decrypt them. We need to highlight that our secret information is never revealed on the device, it's always encrypted client-side, and then the cryptographic key for encrypting and decrypting is not stored anywhere. Actually, it's done on the fly as we enter the password. So for this to be possible, we need to use the single-page application technology, where the whole front end of this website is on a URL, the same one, so you can enter that into the login page, and we can get the cryptographic key, and then we need to send it over to other, well, we don't have to, we just store it on JavaScript, and since the site is on the same URL is there, and we don't have to do anything about it. How do we share secrets with other users?
Vamos a derivar.
Well, we'll end up with two different keys with non-symmetrical encryption, RSA keys. So The server knows the public keys of all users, and other users can only decipher that secret if they have the secret master key. Because you don't want to store all that information on your devices for other people to be able to find your secrets or retrieve your secrets, and then we won't just have two different keys, but further keys depending on security questions. The private key, depending on the password, it depends on the security questions. We send that information to the server, and then if we forget the password, but we remember the answers to the questions, we can still retrieve the key. Right, last but not least, technologies for the front end. We need something powerful, Riyadh, then JavaScript as well, because of all the security functionalities that come with it. For the database, I think because it's a related model, MySQL is best for us. And I will try and follow the most secure pathways and the best practices for security purposes. It will be a fully open source application. It will be uploaded to the hub, to the GitHub. And whoever wants to use it, users, companies, private users, companies, just using a password, they could. And who's going to pay for that? Well, supposedly me, if it's not too much money. Thank you for your attention.
Ubanux. Tenéis este para pasar, con este de la derecha, y por ahí te la enseño yo. Sí, sí. Son 6 minutos, están los dos, el de mesa y el de mano.
Vale, muy bien.
Right, let's start with our application, Blue Fingerprint. Why is it called like that? Well, because of Bluetooth. That's the blue part of it, because it will be using Bluetooth. And then we will be implementing a NFC to make it faster. And then a fingerprint, because a fingerprint will be important, as you will see. So let's start at the beginning. Mobile phones will be identified as unique through symmetrical keys. The user would have a particular key all the time, and so would the mobile phone device. So at the end of the connection, a second symmetrical key will be used so that it can be used the following time through LED or maybe through a serial port. We will be verifying if the device is authorized. And then if you want to add new users, there is the master mobile system to generate the key, and the master would let Arduino have that information so that we can make sure that's a legitimate device that should be accepted. The master token can be changed just by scanning the QR code that the master generates, and that provides a symmetrical key. The following master would scan it, and whoever connects to Arduino would get that following symmetrical key. And the master is the only one who can register users. Now, what security areas are covered from this? Well, confidentiality and saving of symmetrical keys. What about authentication? Well, that's based on a register, on a log of all users in the past. The following feature would be integrity. The idea is that through symmetrical encryption, we just want to make sure that files are not shared unduly with external stakeholders. The master will be the only one accessing the user list. So, why do we have these features as opposed to anything else? We don't have other authentication or identification mechanisms. We decided these were easily implemented, safe enough, low cost.
Vale. En cuanto al público que queremos.
What about our target audience? Who has this type of need? Well, it would be anybody in the community that complies with these needs. Gate-oriented needs that require access through registration. And in the authentication process, well, that would have secure identification. For instance, a lock in the main access to a company. That would be a typical example. NFC projects can also work like this, but we decided Bluetooth might be best. NFC can make the process faster, and we think that it would be an interesting development for the future. But initially, we thought it would be more realistic starting with just Bluetooth. That's right, because it's fine with encryption. Otherwise, Arduino would not see that communication was taking place, and we want encryption. We really want encryption. How did this start? Because we want secure communication between devices and other pieces of equipment with low computation performance or possibilities, or computing power, sorry. This system is versatile, and Arduino is good enough for what we need to do at the moment. We have come with part of the development already. We think it could be a very useful development. It's pretty minimalistic, really, but it can contribute so much. It can be adapted in the future, customized. Let's see how this is going to be working. Arduino would identify the device. Users need to be registered through the QR code. The Arduino memory has to save that, and then it would be encryption, the last step. That's all from us. Thank you very much for your attention.
Vale, Cel. Buenas.
Para pasar la flechita de la derecha. De acuerdo, gracias. Bien, buenos días.
Good morning. Our team has come up with this idea. Stock. Our names, Guillermo, Álvaro, and Ivan. And we want Stock to help users and systems administrators easier. And how? Well, through managing authentication keys more easily, and also helping communications at the server's level, and also keeping users' credentials secure. We can manage access to SSH or any other service so that it can be done securely through an authentication process. And using port knocking technology. Later we will tell you a little bit more about that. We also help automatically supply passwords to users. So, what do we want to cover with this project? As far as users are concerned, we would offer secure communication, managing their passwords, different levels of authentication. And then for systems administrators, we will close access to resources unless they're absolutely necessary. Obviously, always registering and identifying clients and users. Who do we want to target? Well, academia, our universities, laboratories, different organizations that need to limit access to certain users. What is port knocking then? Well, this technology started at the beginning of the 21st century. The idea is that users follow a sequence and an access token to then access a server. That's detected by a firewall, and if everything is correct, permission is granted. In our case, authentication happens within the system by managing the keys, the passwords, as we said, and permits will be temporary or permanent, whatever the situation requires. What about authentication? Well, we have different options there. One is Google Authenticator. This is the GPG keys, the typical technology that USB sticks bring or come with. This is the solution we propose, combining authentication at the user side, although the user doesn't have to necessarily generate the keys or the passwords. They can do so, or they can continue to use their passwords, their keys, but the idea is that keys are automatically managed by the infrastructure. You can see the port knocking mechanism is the one that implicitly authenticates and gives access to different resources as required. You can see that we combine the access mechanism, authentication through the double-factor system, or through a physical password or key. Here we can see an example of how to implement this solution. You can see the customer side at the bottom and the supervision side at the top, which can be isolated from the general infrastructure so that there is supervision in place. That's their role, supervising, that is, the passwords, the keys, a very similar role to what some clouds are doing, for instance, Amazon or Emma. There is authentication, true, but also managing the keys. That's more and more a common thing in cloud systems. Here we can see the LastPass or Google authenticator, or whatever implementation that's in charge of TOTP. This is where the application for services takes place. In that case, a time framework starts where through SSH or whatever that can happen. Here we can see the technologies involved, Ruby and Firebase. You can understand this is completely outside the infrastructure, so that there's no risk of security breaches. And then Python and Docker at the customer side, at the Python side. That's all that's required for the infrastructure. We have been searching and finding, just documenting for different possibilities for the solution so far. Thank you very much for your attention.
Sí, tengo yo un segundito que os cambio esto. Sí, ahora os lo pongo, se ve.
Puedo contar los píxeles.
Vale, tenéis aquí pasador, el de la...
Cógete el mando tú. Yo puedo pasar con el... Sí, ¿no? Sí. Cógetelo tú. Vale. Buenas a todos. Somos Ángel.
Good morning. Our names are Ángel and Miguel Ángel. And here is FastFish, a proposal for this platform to detect phishing in any environment. We don't need to analyze documents, or it's quite generic, providing both active and passive protection. And this is not just smoke. You will see how. It wants to be an efficient and scalable solution, because we feel that what is currently available doesn't comply with those basic features, and it has to be modular, we think, so that people have what they need, no more or less. Here we can see how we start with analysis on demand for customers. That is, it can be a DNS server responding to users' queries, and then the service could just block, thinking it was something malicious. Then it can use both blacklist and whitelists. There's another layer here, which is interesting then, new, where we compare the canvas generated by HTML, for instance, comparing Twitter with Twitters, or different alphabets that different languages use. And then there's the layer for email analytics, not checking the files that are that come in your emails, because that's already checked by the antivirus. The application would be crawling of different potential links that could be malicious, and pre-checking them before users even require them to be checked. There's also transparency, which is quite innovative, so that domains can be checked just a few minutes even after they've been registered, and all of that with really updated databases, so that we can use databases that have already been analyzed by other teams. And why do we think this project is important? Many companies are doing phishing, accessing credentials, and not just through an exploit that accesses on a zero-day human resources database. Most phishing cases are not based on Trojans or exploits, but through a captive gateway, getting users to send you their credentials, because users are much more easily cheated than systems. This is a bit peculiar, but this is fish tanks. Users upload cases that they think are phishing, and if a certain number of users vote that that could be phishing, then that's studied and analyzed. Look at that. Between October and November, most phishing cases, even over 80% of those, were finally scored as positive. That means that phishing detections are often phishing at the end of a day, and there are a lot of them. So this platform will help all sorts of organizations where this might be compulsory for all users, or sometimes for private individuals at home. It could be a little bit of a complement to Chrome, for instance, or sometimes where you have 1 million URLs, it can also cope with that volume and tell you which ones might be phishing. What technologies do we want to use? Well, we want to be fairly open with that. We want module communications to be diagnostic. The backend for the moment will be Go, but depending on our resources and time, that might change. And Redis for our cache. And then we don't want to use different ratios. We want to have a domain and then end up with a certain percentage telling us whether it's going to likely be phishing or not. There are sort of similar tools. The second one that we can see up on the screen, in fact, is based on the first one, but they come with quite a lot of bugs, or, well, not bugs, but they're a little bit incomplete. The certificate transparency is not complete. They're not modular. They're open source, but developments are pretty complex because they're not modular. No metrics, and also they're not scalable. Or they work with a binary code that you run and you just leave it at that. So what are we going to be doing here? We didn't bring anything that we made earlier. We haven't written any other code, and we want to end up with the core, at least the basic part for passive analysis of domains. Also an analytic module that can then provide the analysis, and then the on-demand queries. What else will we have? Well, integration with the databases, and that's all from us. Thank you very much for your attention.
Buenos días a todos. Nosotros somos.
Good morning. Our team, Tigris, wants to tell you about our proposal, AeroHeat, for Wi-Fi captures with a tool we will describe. There are 4 of us in the team, 4 tigers, Raúl, Silvia, Ricardo, and my name is Elena. We work together as cybersecurity analysts at the same company, and now my colleague will tell you more about our tool. Well, the main features we want to cover are the following, starting with iCrack. With iCrack, we will end up with a database which will in turn generate heat maps. different tables and statistics on that first capture that can be analyzed at a later date. All of that with a web interface. And then one of the tables that we want to implement will list potential customers and possible breaches. What about our target audience and application? Well, we want to target cybersecurity analysts interested in Wi-Fi and anybody who is interested in passive capture of Wi-Fi networks. And as a user case, we want to see a coverage analysis, range analysis on the basis of the heat maps. What is in the market in this sense? Well, there's acrylic. It works very well, but you have to pay for it. Also, we wanted to have something which is multi-platform, which is why Aircrack might be better, which works with Linux, but it can also work with Windows, and all of that with a web interface so that there is agility and scalability and usability, so that is user-friendly. We're going to start with the Aircrack code, then we're going to have access to the database for queries, adding information then that doesn't come by default. And then after that, we want the design of heat maps, information tables with the customers, the probes, for analytics to be possible. All of that has to be implemented on a web interface. And if we have time, we would like to have a little add-on module, Bluetooth scanning program with GPS, so that can be included with the tables. That's all from us. Thank you very much for your attention.
Perdona. CBNet. Sí, que se me... Sí, la tengo. Vamos. Si la veis mandada, aquí estará. CBNet. No. Vale. A ver si me deja sin repararla, que no proteste. Ups, dice que está vacía. No, pero prefiero que, para no retrasarnos, voy a pincharlo otra vez. Es que dice que está la unidad bien. Entonces vamos a intentar repararla, pero ¿estáis seguros que está aquí el...? Si es que no aparece el fichero, vamos a ver si la repara rápido, lo podemos comprar. Y si no pasemos al siguiente y ahora cambiamos. Es que aquí desde luego no está. Ahora no me va a dejar el CD, pero... Esto está vacío. Sí, vale. Es que un segundito. On tick. Ahora me la traemos. Aquí a los mandos. Au.
¿Empiezo? Hola, muy buenas.
Good morning. Welcome. My name is Alfonso, and together with Alex, Germán, and Alfonso, we make up the antique team. We were part of the Black Razor conference. We have won the last 3 years of this hackathon, and we hope that you don't find that intimidating, but rather that we can egg you on to beat us this time. We're going to try and give you good advice to do so. This is our tool, our proposal. Juris, in Latin, it means law. The idea is that this tool will help us verify and comply with different laws and regulations and legislations in an autonomous manner. We have there a short list of some laws and regulations we want to address. And this tool has 3 main roles. One is analytics. It will be analyzing websites that we supply. Then it will have different technical details that it will cover, and we will welcome any proposals and ideas that you can give us for that. It will cover legal texts. There will be an assessment and evaluation after that analysis, with then finally recommendations. So what is our target audience? Well, really varied. Sometimes professionals, people who work with testing, people who own websites and want to comply with regulations. This could be an interesting tool for them. Also, private individuals, normal users who browsing want to know what legislation they should be complying with. And we know that in the European Union and public institutions in general, more and more laws and regulations are coming to the forefront, sometimes with very heavy penalties if we don't comply. Now, there are different possibilities at the moment, Acunetics, OpenVIS, but they don't focus too much on legal details. If you want to audit legal websites, you need to read very long-winded, complex legal texts. There are different forms, there are different checklists that are available, but it's a very manual process, really. We feel it's about time that we have an automated, autonomous tool that can do so for us, so that you can use it even if you don't have very technical knowledge or legal knowledge. What do we need technologically? Well, a core running the program as such, and then an interface, GUI. We will be using PHP because we're good at it. We haven't decided which database we'll be using yet. We will welcome any suggestions. We'll be using JavaScript, HTML, and also Selenium that helps test websites. What did we come with? Well, we haven't developed any code. We haven't written one single line of code. And what we wanted to have as an objective for this year is ending up with a fully completed tool at the end of the hackathon. We think this will be complex. Why? Because we want a rapid, scalable code. That will be hard. And also the fact that websites are really heterogeneous. Detecting cookies or a number of things like that is simple, but not types of texts and so on. We still haven't decided what information will be displayed by the GUI. What benefits will our tool bring to our community? Well, we'll be using open code. It will be an autonomous tool. It will be covering some needs that are at the moment uncovered. It will be very integrating new technologies, different technologies. Again, we will welcome any suggestions from you, and then also because it will be collaborative design, we can then add different legislations in future, and also it will be able to cope with different languages and translations. We very much look forward to your questions and comments later on.
Recordad que nos gustaría que...
Do remember, we would like to have the questions right after the presentation, but we thought you will all be given the same opportunity, and afterwards we will have the Q&A. And just to encourage you all, it is not just you who is nervous. I was as well, and I think I call Alice Guillermo, so my apologies. Some of you look a bit more nervous, but don't you worry. This is the opening presentation, and even if it is important, as we said, we are well aware of that, right? Good morning, I'm Emilia, and I'm part of the ZevenNet team. First of all, let me introduce you to my team. We are colleagues at CVNet, and we are operating system developers. We develop routers for apps, specifically what is known as service routers. These are Alvaro and Lara, Luis and myself, Emilia, that is. So we are facing real problems as we defined with our clients. If we ever need to protect the security of a system, we realize that the protection standards cannot be generic in its scope, because that's where the protection is so very much needed, and that's where the data flow is the highest. And a pattern that can be identified as an attacker cannot be an attacker for another app running on the same device. So the first problem we bring here is that data flow, the networking devices use different data flows on which we need to have different security measures. Then another problem is that when we talk about security, safety and security, regardless of what we are using on the operating system, is very costly. So we need resources for CPU and memory management. So what cases do we bring here? What case reports can we bring as for security? We can use security in order to protect from DDoS attacks for perimeter or peripheral firewalls, or even load balancers. This is all about security management and how to protect those balancers. And we can also use this technology that I'm about to show to you for the security and protection of any kind of communication channels, a cloud provider or an internet service provider. So what we propose here? So we try to find a resilient security system. What I mean is that it is feeding back into itself. We will avoid any kind of log analysis so that we do not detect the attacker post-mortem, and we will follow real-time security standards. We feel that a good security system is just a system where there is a defense of patterns on different layers. Here you see two basic layers for the RC model, which is transportation and application layers. There are other protection systems that can be targeted for a given layer, such as antivirus, but we feel this can be a deficit, and we need to use information from different layers, which can be very useful and difficult alike. The target audience would be any system that is exposed to the internet. This is our proposed diagram or flowchart. On the top of it, you see 3 users that try to log onto the load balancer, on top of which we have the security layer. This is request 1. This is a regular user that logs onto the network device, detecting the flow to be identified and resends it to a lower layer. That's where the user is now. Here you see an L4 signal. That's where we try to see the attack protection analysis using SynFluid or others. Once the device has identified that the attacker is not malware, it is allowed onto the next layer. For L3 and R2 and R3, we see malware. There is abnormal behavior. This is an L4 attack, such as an AirFlood or SynFluid. It is identified and taken to the blacklist so that it doesn't go through the next stop or spot. Then we have another attack, which is not abnormal, but is actually trying to have an SQL injection or HTTP attack, which is L7 attack. Next attacker would jump on to the next node, that is management layer, where we have security systems identifying content, and once the attacker is identified, reports back to the first level, so the firewall won't allow that device back in. So this is a firewall that it will be developing, as a matter of fact. And so the next time around, on the next login flow, R3 will never go through the data channel all the way to the destination. It will be blocked away on the initial step. So what are we going to develop? We will develop, so we are using open source software. It is on our GitHub, and there's something we're working on, and Laura is now in charge of that. And it is just a standard modular with advanced intelligence for traffic management. This will be the one for the firewall, seeing the abnormal behaviors that we're tracking and see what the attacks are. This is the first layer of security. Then the next layer that will be developed, it is Lewis scripting that is in charge of the application, and once the app has identified it is an L7 attacker, it will report back to NFTB, and so the attacker will not be allowed through once again. We work with the kernel space mainly, and others where we can optimize. We will also have an interlayer interaction, and we'll also use kernel blocking events where the package leaves the board and goes into the kernel. The earlier we manage to lock the user out, less CPU will be used and more efficient will be. That's the key to us. Expectations. Attack detection is costly, and with this technology we'll try to use less CPU, and as I said before, we try to identify attackers in different layers because we see there are different kinds of those. And that's all. That's the proposal for security.
Unicorn team. Vale, un segundito, que es un PDF. de la derecha, eso es.
Ya, vale, sí. Vale. Buenos días.
Good morning, everyone. We are José Ignacio Esquivano, Nerea Saez de la Manza, Jorge Cuadrado, and myself, Ruth Gonzalez. We all four work at the Innovation Department at BBVA Next Technology, and we're here to bring you our idea as ASAP, Anti-Shoulder Surfing Attack Platform. That's what it stands for. Why did we decide to focus here? Well, most of the apps and research focus in other things, which are mainly security of systems, security of communications through secure protocols such as HTTPS or encryption, or else solving and patching up vulnerabilities, whether operating systems or problems with the app itself. But we should like to focus on the end user. The end user is the one using the devices on a daily basis, and oftentimes unaware of the risks they are exposed to. And in the end, this is the weakest link. We want to provide them with a tool that understands what is being done, and so that it can be easily used. So what's this attack, this shoulder surfing attack? When you're working on a public space, whether on a train or an airplane, or even at the office, and they are handling sensitive information, there may be someone behind their shoulders watching over them, seeing what they're doing. So if you're working with sensitive information, or entering your bank credentials or social media credentials, or anything that can be the least bit confidential, someone behind you that sees it has all the information. Does it matter that you're using HTTPS or everything else? When they have the password, they're in. So anything similar? Two things found. One, which is HP proprietary solution, where on the screen there is an added layer, so the users from a different angle from the main user's angle, they cannot properly see what's being entered on the screen. Then another solution would be screensavers, which is just a film on your device, and from different sides you cannot see. If you are sitting on a train, the one sitting next to you cannot see, which is good. Problems with these two solutions, they're hardware. First one, if you don't have an HP, it doesn't work. Second one, you need to get this saver and you need to stick it properly, or otherwise it is ruined. We wanted software so that any user can have it on their device and just set it up and you're ready to go. No sticking, no HP. What we offer is more than enough. What about the goals? Long-term goals would be developing an app that is multi-platform, running on any device with a webcam, whether Windows, Mac, or Linux. We also want to perform different actions. If we see the attack is going on, the user can set up what they want to be done, such as minimizing the screen, changing the brightness, or locking the computer out. This is to be decided by the user. And then we want to use several machine learning and artificial intelligence models, which can be online, as provided by Amazon or Azure, and then run them on the device itself. As for our project, we decided to use web technologies, because if you ask us, that's the future. We want to focus on HTML, also JavaScript, JSON, and also an open source library for artificial vision, and Amazon Web Services for cloud services. And with Electron, we will make sure that this app is a multi-platform app. We are bold in our project, so we had to narrow down the goals in order to fit into the deadline for the hackathon. We want to have a proof of concept working on Windows, Mac, or Linux, and we want to use different machine learning models as well as artificial intelligence, test cloud models, and also on live models. And of the subset of actions that we can have with the attack, we want to choose one of them and add them to our app. Current status. What we've done so far is checking out whether it is possible to make our idea real, and we've chosen technologies, but yet in the repository there's nothing. It is empty, as empty as the desert, and we find this is a good opportunity to start out. And that's been all. Thank you very much.
Local.
Localt host is next.
Y los dos micros, sí, los dos. Vale.
Buenos días. Nosotros somos los...
Good morning. We're here to introduce you to Enitsta. Here's Jorge, I'm David. He's coming from Madrid, I'm from Malaga. And we met on previous projects. We are online gamers and we've always exchanged ideas on security. Enitsta, well, it came up because of the information sent by our devices, whether a smartphone or a laptop or a DT device on the MAC address, whether it is Bluetooth or with Wi-Fi. So the information we'll be using, that's it. That's the information. Before the project, we researched or looked into the devices with random MACs or devices that also send the MAC address. And so we want to use SP32 devices, which are small microcontrollers that are battery compatible, and it is easier than doing so with any classical USB parsing or using SKP or anything else. SCAPI project, sorry. And this is experimental. This is not a system where the main idea would be to gather intelligence from people surrounding us, but rather this is to be easily set up, and it has to be cost-effective and done by anyone without significant cost and without a fixed system. So if you want to move it elsewhere, the device, it is easily done and it still works. We also need to understand that this is a passive system, so that means that there will be no attack on the devices found, because the basis for the detection of the system would be a black and a white list. So devices we believe are positive or good to our network, and those that are malicious. We will not call those, well, not malicious, rather, let's say that we will not lock them as a blacklist, but if they registered the MAC address, the user, they can add those MAC addresses to the blacklist. As for similar projects, I can only know Meraki by Cisco, and well, it is expensive, and it's not an easy infrastructure to set up, mainly because of the cost. And the main focus is for it to be, for my project that is, to be cost effective and so easily implemented. Then there's this other idea, was using ASP32 because of a previous project where we tried to use triangulation by using different SP devices, which is the chip before SP32, and we were gathering the same information together with M66 of connections, and we decided to turn to SP32 because it had an embedded Bluetooth. And this is why we used it, because of the price and the documents abundant on the internet, but mainly on the API that has been implemented, and not so much the Expressi SDK, which is the chips brand, and the backend. We will be using Django and also REST framework. Token will be used for identification, and information detected will be sent regularly. This system will have also the lists running, and if the MAC address detected is malicious or not, or we see that it's an authentication attack on the network, there will be an alert for the user, mostly real time. So within the perimeter of the network, there is an intruder. And Jorge is about to explain in further detail the tests we've conducted and why we've chosen it all. Hi. So we've got here SP32 devices, and we will have several spots for gathering information, also a Raspberry Pi with us to have the server and access and have information from all the SP's devices. With SP32, we've run tests in the past. We've programmed with Arduino, where we see that is compatible with SP32, but then we've stumbled upon memory problems trying to gather Wi-Fi, discovery with Bluetooth together, and also HTTP transmission that is to be secure. So this will be delivered as software, add-on software, but we had to start from scratch and checking it from the expressive software from scratch, as I said. With the Raspberry, we will be implemented data collection and storage, and then also the way we manage information. And then I will mention that on the next slide. ESP32 do not have support from a 802.W, which is for authentication. So this is a problem because they can cut us off the transmission in our devices. That's where we'll be running something on the Raspberry Pi so that it is in control of the authentication in the area, and also send a warning if someone is trying to authenticate our own ESPs. And then, what about the software we will be producing? It's open source. We will have it on GitHub, and that's it. That's been all. We will be sharing other ideas we've seen. There are so many projects on IoT. We deal with lots of information, and this is going to be good to unify ideas. Thank you very much.
Bueno, pues gracias a todos por las...
Thank you, everyone, for your presentations. As a matter of fact, this activity, well, we started it last year, this open public initial presentation, so that you, all the teams, you are aware of what they are working on, others, that is, and so that you can also find potential synergies amongst you. So instead of having a competition, we want to have that kind of a community where you all cooperate together. In that regard, let me say that when it comes to cooperation, you will be rewarded, and it adds points. It adds to your score. So you will be our reference. We will be paying attention to you, but you need to see what teams helped you out, which teams gave you extra support to get out of obstacles and giving you some ideas. So you need to be aware of that as well. And then with the time that we have left, as we said, we only have limited time, so I'll explain the rest of the standards and rules and move to the room next door with a hackathon, and that will be the Q&A, and the jurors and the teams will ask questions. And then you can also ask other teams, whatever you have, ideas, comments, the way to help them with their projects. And if someone here that might not be part of the hackathon wants to come in to listen to the questions and to discuss some ideas, they will be more than welcome.
Pues donde nos quedamos fue la parte de...
So this is where we stopped earlier on. Let me remind you that during the competition there will be a screen with slides as reminders with competition rules, including the repository of GitHub from different teams, so you can monitor that. And times are important. We told you by email that we need to be very, very respectful with the times that we've been given in this room. And because of that, we now need to go to the hackathon room to continue with the Q&A session. And then after that, we will start with the first landmark for that will count for the final assessment, for the scoring. Members of the jury also will be visiting you regularly to ask you questions, to solve any doubts. Let me remind you as well that we should be stopping for lunch at around about 2:30. Lunch will be served from 2 up until 4 o'clock. You can go and have your lunch more or less at any time in theory, but we would also like to do a little bit of networking at lunchtime, so why not all stop more or less at 2:30. We will be telling you partial results and outcomes for this first landmark, and you know that the identifying code for your team, the hexadecimal code you've been given, will be what you will see for scoring. Tomorrow you can start working at 6, although at 11:30 we will have the official opening of the CyberCamp that you are most welcome to attend. Then, as I said, members of the jury will be visiting. 2 members of the jury are experts at code, open source code analysis, which is time-consuming. And members of the jury will be taking it in turns with those different roles. You will continue to work with teamwork up until lunchtime, more or less at 2:30, and then also you will prepare to come to this room for final presentations. Unfortunately, we have very limited time, so please make sure that your connections are working, that it can all be screened and presented conveniently without any hiccups. We will have 11 minutes per minute. That's the limitation. And we would like to give you as much time as you need, but we will have to be very strict. We have a long list of teams, and we have to make sure that we respect the times, also thinking about the streaming of the activity. Round about 6:30, the jury will be meeting for deliberations. And let me remind you that you have to look after all possible details for that to go ahead. Round about 7:30, 7:45, we will be publishing the final results. Meals are all organized here. That's been a good improvement. Lunch and tea will be served. You were telling us on Telegram that you were a little bit concerned that you would go hungry. Well, don't fret, you won't. And there will be a final celebration for those who survive the hackathon. We encourage you to join in, but that's voluntary. We still don't know where we will be celebrating. We have checked different possibilities for venue, and because it's Saturday evening, it's going to be on Saturday evening, we're a little bit limited with that. Then the award ceremony will be at the main auditorium as part of the CyberCamp closing ceremony at 2 o'clock on Sunday. There will be 1 landmark per day, starting today with the first one, and for each of those landmarks, at least 1 member of your team should be there to explain to the jury your landmark. The last landmark is number 3, and that's mostly your final presentation. Don't worry about taking down all these notes because later on we will be giving you a sheet as a reminder, and also the hackathon room screen will have this list as a reminder. Again, please look after as much detail as possible, just to prove what you have managed, your outcomes, and for scoring. The members of a jury, their deliberations will give some 94% of your final score, and the remainder will be depending on what other teams say about you. We would like to ask you to please be very honest with how you assess other teams. In previous editions, and there have been teams that didn't score the best teams because they didn't want them to win. So please be honest. And there's a collaboration bonus we've mentioned before. Some 5% of the final score will come from the questions and comments that you make. Then another 5% as well will be given to you if you help other teams, and the issues that you've solved for others. And that's how we have organized the final scoring. We know who will be presenting when during the last final presentations, and then you will be given the criteria. You will be given a sheet as a reminder as well. Every criterion will be assessed twice, and for landmark 3, by that time, you should have a functional GHub of your GUI GitHub. We will have different rounds, as we said, for questions and comments from the members of a jury, and there will be specific tests for functionality, for security of your tool, analyzing your code, how you manage the issues that are opened during the process, and so on. Landmark number 1 has 15%. That's the weight of the final score. And here we can see the criteria that will be assessed: functionality, application methodology. Anyway, this is a little bit of a repetition of what has already been said. In landmark number 2, well, we'll check the structure and quality of the source code, if it's clean, easily readable, what type of algorithms you've used, your libraries, how flexible your options and parameters for setting it all up is done, the command lines, and how you manage your issues once again. Last but not least, documentation. Part of what will happen will depend on users being able to implement your tool just with the instructions that you give. Landmark number 2 will have 15% weight of the final score, and landmark number 3, 75% as the main one. There will be a round of questions as well. And we decided to give the final presentation 1 extra minute. Unfortunately, because there are so many teams, the final deadline, the final time, will be 11 minutes, just allowing for any possible hiccups or technical problems that might occur. After the last landmark, there will be assessment from other teams and the collaboration bonus. Once again, the idea is that we want a hackathon that is truly collaborative. We feel that collaboration, when it happens, it makes the most of possible synergies amongst different teams, and that's added value. Now, the additional 15% of the score will come from questions, partly, depending on how relevant they are. Also, be careful with the issues that you open. Don't just go crazy, and just make sure they're relevant. And again, collaboration with other teams, it will depend on how relevant your comments or queries are. Some of you are experts at winning competitions. I'm looking at Antique, that team now. You will be given a professional. Here we have the 3 prizes that will be given, different IT hardware. And also we want to have different winners for those 3. So the team that has the special mention for students, if it's one of the 3 winners, then they won't be given that. It will be awarded to the following team. And we want to have anonymous scoring, and that's why we've told you you've been given a hexa code. So you will only see that code and the relative ranking for your team. We decided to have that system because sometimes the difference in the scoring is very, very slight, and also because we don't want teams to be discouraged. Sometimes you might rank 6th on the screen on the table, but there's a very, very little difference with. Yeah, that's true, because I remember that the team that came last during the way all the time was finally the winner. That's true. And on Landmark 1, the team that scored least points was finally, more points. They were the losers. They came last at the end of the competition. We also decided to have reverse order for the final presentation, so we don't want the same team to have to break the ice both times. Here we can see the updated table for the final presentations. So Raúl is now going to give you some final messages, but if you have any doubts or questions about the competition, now is the time for you to ask. Let me insist once again that for us collaboration is key, and we also want the jury not just to be there to assess the teams, but also to answer questions. Any doubts you may have, please ask them for guidance. Don't think the jury is your enemy, but one more ally or partner for you. Any questions or comments now about the competition, or is everything crystal clear? Again, if you have questions later on, just fire them. Let me continue now with some practical messages. Look at the screen. That's the resolution that we will have. Unfortunately, you know that letter type, the size of the font will be key. And Oscar reminded us yesterday, we have warned you on Telegram in our messages. And Monica said that time will be fundamental. This presentation has been 6 minutes, but the final presentation will be 11 minutes. And you're going to have to be totally independent with your own computer, with virtual machines, so you can run the demo. That's quite risky, so please test everything, check that it's working, and this room will is right, that HDMI final presentations will be at 2 o'clock on the last day. Yeah, please be real professionals and check the presentations beforehand. Don't leave it for the last minute and think that your audience is going to have to sit and wait for you. Make sure that you come nice and early, check that everything is working, and then, okay, something might go wrong at the end of the day, but it won't be because you didn't check it. Those of you who will be using demos, virtual machines with hardware, with Arduinos, and so on, please remember that space will be limited and make sure that there will be room for everything. Collaboration amongst different teams will be important. For instance, for Wi-Fi heat maps, some of you will be working with different areas. And about the source code, so that it can be assessed regularly. Well, please upload it regularly, even if it's not the final version. Please don't leave it until the last minute, until landmark number 2 starts. Please make sure that you upload it so we can start checking. For those of you who will be uploading to the cloud, I think for the demo on the last day, if it were me, I would come with my own equipment, with my own system. Today, we've all been using the same PC, but I think that that won't be best for the last day. Make sure that you have HDMI VGA for visuals. Just make sure that you have everything ready and you can test it, or even you should test it. You will have 11 minutes for the final presentation, and one image is worth 1,000 words. So don't leave too much time for slides, for general explanations. Oops, we're being reminded that we need to leave the room. We need to set a good example, be good role models. So let's respect that and go to the hackathon room. Enjoy.